Activity 2, balancing chemical equations. This gives students an opportunity to first relate their idea of the law of conservation of matter to why chemical equations need to be balanced, and then give students an opportunity to practice with some visual models to improve their skills with balancing chemical equations, or learn to balance them if this is their first exposure to that task. In the What Do You Think, students reflect on possible differences of the meaning of the word balance. This is an important idea to make sure that when you use the word balance, students are thinking of the word the way you want them to think of the word, as opposed to some other meaning. This Investigate is divided into 3 parts. In Part A, Is Matter Really Conserved?, students are asked to design an experiment to see if the amount of matter present changes during a chemical reaction. They're provided with a list of materials and asked to design a procedure. So students are given chalk or calcium carbonate, hydrochloric acid, and then a balloon, a rubber band, a flask, a beaker, a graduated cylinder, and asked if the amount of matter changes when the reaction takes place.
Okay, so we're going to measure these.
When your students are designing their procedure, you have them very clearly indicate what they're going to measure before and after, to see that they're measuring everything and taking everything into account, not weighing the flask twice and all of a sudden creating all this matter. It's something to be careful of.
5.33 grams.
Shall I do the honors?
One thing students will want to do is, since you've provided them with a graduated cylinder, record that they've used 10 milliliters of hydrochloric acid and then try to add that to 5 grams of chalk. And you have to be very careful with them that they can't combine a volume and a mass measurement and say that it's 15 grams or milliliters. In addition, you'll want to be sure that your students are aware that they shouldn't be weighing things directly on the balance pan, no chalk directly on the scale, things like that.
We can subtract the balloon weight and the flask weight to get the total mass of the products.
That's correct, because the mass of the balloon and the flask don't change during the reaction, and so their mass stayed constant.
Right.
That sounds good. So what I'd like you to do is go ahead and do those calculations, and then let's see if you can provide some evidence for matter being not created or destroyed during chemical reactions.
Okay.
Some students may choose to go about this in a different way. If they may use the Ziploc baggie, sometimes the students use the Ziploc baggie and put the chalk on one side, the hydrochloric acid on the other. Use the rubber band to tie off one end. Weigh it before, weigh it after. That's usually evidence of a pretty creative student that can think outside the box. If students don't come up with identical mass measurements before and after, that's okay. You can discuss with them what their reasons for experimental error were. If they're using the balloon concept, it may be that some of the gas escaped before the balloon was put over the cap. If they don't like that idea, you could ask them, well, if you have a balloon in your house, will it stay inflated forever? And they come up with the idea, no, over time it's a little bit permeable, things escape. So this idea of it's not a completely constant system. It's also important that when after your students design this experiment, that they show their procedure to you first, because there is the danger, if they're using the Ziploc bag, that they may produce too much carbon dioxide gas and the bag could pop open. So in the teacher's guide there are instructions for, depending on the size of bag you're using, the appropriate maximum amount of chemicals that students should list in their procedure, and you would want to look for that.
So you guys learned in Part A, and your data showed that the matter weighed the same before and after the reaction.
Yeah.
And you remember that chemistry is all about representing things that we can't see in symbols. And we've got to make sure that our symbols accurately represent what's really happening in nature. And so we need to make sure that when we write our symbols down, our symbols show that matter's not created or destroyed. And so in the next part of this activity, we're going to be looking at some models to help us understand how atoms rebond, form new bonds in chemical reactions. So you're going to be using these molecular model chips to illustrate different kinds of chemical compounds.
In Part B, you want to relate for students this idea of, here's what nature does. Matter is conserved. So if we're going to, in our symbols, write down things about matter, we need to make sure that matter is conserved. You're going to be using either bingo markers if you have those, or you can use the colored discs to represent atoms, or later even to represent groups of polyatomic ions. They're different colors, so students can assign a color to a particular element or polyatomic ion.
Let's have red represent iron and blue represent oxygen. Okay.
Okay. You might write that down on your paper too so that you don't get confused.
This particular activity has a lot of different levels that you could choose to take it to, depending on the background of your students and the depth to which you need to go for your state standards.
So tell me how you guys are doing this.
So what we realized was we need 3 iron, or 3 oxygens, which is 2 irons.
Okay.
And so we're representing our irons as red and our oxygens as blue.
Okay.
And as simple as we can put it, we are putting them so that they're all touching and making one molecule out of it.
Okay. So since they're all touching, that represents one molecule.
Yes.
So is this your final answer?
This is just one of them. There are 4 iron oxide molecules, so we need 3 more.
Okay. So because of that that large coefficient 4, that tells you how many sets of that you need to make.
Yes.
Okay. And then in part C, they move to balancing equations with a more traditional question, just analyzing the reactants and the product formulas. So students are instructed to look at equations, look at formulas, count, practice one more time, being able to look at a chemical formula and know how many particles are there. Then they are broken up into groups and assigned a chemical equation, and then they're asked a series of questions to help them decide if the equation is balanced or not. The Chem Talk of this section deals with the law of conservation of matter and relating that to its historical significance and its discovery. You have the reflecting on the activity and the challenge to remind students that chemical equations and reactions that they choose to use in their Dominoes device, they're going to need to know how the particles relate to each other, so they'll know how much materials to use to maybe inflate their balloon. And then in the Chem to Go, you have some more traditional practice of balancing equations and considering multiple choice situations, being able to identify the correctly balanced equation, and so on.